Hey guys, welcome. In the previous episode, we have seen the difference between traditional programming and machine learning algorithm. Then we have seen the difference between machine learning and deep learning. And then we have seen this definition. So deep learning is a technique which is capable of learning complex patterns from data using neural networks. So what are these neural networks? A neural network or artificial neural network, or also known as multi-layer perceptron, is simply a network of neurons. Now, what are these neurons? A neuron or artificial neuron or perceptron or node is a very simplified mathematical function that mimics the working of a biological neuron. So guys, if you want to know more about the definition of neuron or perceptron, you can go through this Wikipedia link. This link contains good definition and a little bit history of artificial neuron. So I would suggest go through this link. Now let's go back to our neuron. Now this is the equation of a neuron. You can see, so this is called activation function, B is called bias, W is called weight, and X is called input. And if we simplify this equation, it will look like this. Let's say we have a neuron and we have a single input. Then our equation of the neuron will become Wx plus B. If we have two inputs, our equation will look like this. And if we have n number of inputs, our equation will look like this. So as you can see here, each input to our neuron has a weight associated with it, and our neuron has a bias associated with it. If we expand this idea into a neural network, it will look like this. So we have connections between neurons, and each connection has a weight associated with it, and each neuron has a bias. So this is called input layer, these two are called hidden layers, and this is called output layer. This is called input layer because our neural network receives input through this layer. These neurons, they do not perform any mathematical operation, they just receive the data from the user and then pass it to the network. Our neural network learns the pattern through these hidden layers. These are called hidden layers because they are not explicitly interpretable either from input or output. All the calculations are controlled by the neural network without any human supervision. And this is called output layer because neural network gives us output through this layer. So when we say like we are training the neural network, we are trying to find the best values for these weights and biases. Hence, for this network, we have a total number of 29 trainable parameters. Now let's look at this overview of how neural network works. So here we have our neural network and we have this image. So here our task is to identify whether this image is of a dog or a cat. Now first we will convert this image into numbers. This is because we can understand the image by just looking at it, whether it is a dog or a cat. But computers, they do not understand the image by just looking at it. Computers understand number. Hence, we are converting this input into numbers. And this is called numerical encoding. Then we'll give these numbers to the network. And our network will try to learn the patterns or the feature from these numbers, and it will give us an output. As you can see, these are also numbers, and then we'll convert these numbers back into our required output. So this is an overview of how neural network works. Now let's understand the importance of weight and bias through this example. Let's take this dataset. This dataset contains house price at a certain locality. So let's say we have a 5000 meter square house. For this house the price would be 14.5 lakhs, and for 10,000 meter square house the price would be 15.6, and so on. So if I ask you what would be the price for a house with an area of 45,000 meter square, so by just looking at this table you will probably try to figure out the relationship between these numbers. I'm sure you will figure out the price of the house with 45,000 meter square area, but by just looking at this table it is very difficult. It is not that easy to do all the calculation quickly. Now when we plot those information on our coordinate system, those data points look like this. And now if I ask the same question to find out the price of a house with 45,000 meter square area, you will think like, okay, these data points, they follow a Lilium pattern. Hence for 45,000 meter square area the price would be around this. The price would be around 54 or 55. So remember, you don't know what would be the price, what would be the actual price in the future. Here at this current state you are just predicting, you are just approximating the price based on the pattern you are seeing here. In your mind you are creating a straight line which can pass through all these points like this, and then you are calculating, okay, it will fall around this, and mathematically we can represent the same straight line by this equation. As you can see, this 1.05 is the slope of the line, you can see, and this 7 is the y-intercept. So here we are representing your idea, your linear pattern through this straight line, and you can see this equation nothing but the equation of a neuron. See, x plus p, x plus p. What happens if these points fall on the fourth quadrant, just like this? So by controlling the weight and bias we can shift the line just like this, and here you can see we have a different set of weight and bias. This is the line, but this is the linear pattern which we can see our data points follow. Similarly, if our data points fall on third quadrant, we can modify weight and bias again to get the required line, and same thing we can do if our data points fall on second quadrant, you can see here. So this is the importance of weight and bias. Then you will say, listen, there could be multiple lines which could pass through these data points. Then how would you find the best fit line, or how would you find the best weight and bias to represent our data? To understand this, let's say there are only these 5 lines which could pass through these data points. Let's understand how to choose the best line for our data set. So this is our data set. Now let's take our first line, and first line looks like this. Here weight is 1.2 and b is 5, you can see. Now we'll calculate how far these data points are from this line, and we'll represent that calculation in form of loss. So we'll calculate that and we'll represent in form of this loss. The larger the loss, the farther the data points are from the line. So for this line we have a loss of 7.54, and don't worry about the calculation, we will see about the MAC loss or how this loss is being calculated in the later video. Now let's take another line, and for this line we'll calculate the loss again, you can see here. After calculating loss for the second line, we'll compare both the losses and we'll keep the line with minimum loss. Now we have the third line and we'll calculate the loss again. As you can see here, we have a new minimum loss. Hence, we'll keep the third line and we'll discard the first line. We'll do the same thing for the next line, you can see here. Now we'll calculate the loss again and we'll do the comparison again with the third line. You can see, you can clearly see our third line has the minimum loss and hence we'll keep that line. Same thing we'll do with the fifth line, you can see here. So out of these 5 lines, you can see our third line is the best fit line for our dataset. Hence, we will keep this weight and bias for our neuron. So this is how we'll choose the best weight for our neuron, and this is nothing but the training process of our neuron. So guys, I hope you understood the concepts of weight and bias. You understood the importance of weight and bias. In the next episode, we'll be talking about what is an activation function and why do we need an activation function in our neural network. So guys, subscribe and hit the bell icon to learn more. I'll see you in the next video. Till then, take care.